environment like C++ or VC++ or VB6, and they have their own compilers, they have their own runtimes, they have their own way of doing the memory allocation. Explain the importance of garbage collector. Garbage collector is a background process which keeps running continuously and claims any kind of unused managed resources. I stress this two words, unused managed resources, right? So if there is any unused managed resources while your .NET program is running, garbage collector comes now and then and starts cleaning them up. For example, you can see here I have a very simple program which is a for loop, which is running for a very long period. So this is creating customers and then disposing them. This is creating customers. New fresh customers are getting created, right? Customer objects are getting created. So now what will happen is garbage collector will come after some time, right? Undeterministic time, it will come and it will clean these objects. So if you see out here very quickly, we can just see this in the profiler. So you can see here, this profiler will help us to show or help us to show that when the garbage collector runs. So you can see here very quickly, I'll just zoom in, right? You can see first the memory was rising, so like new customer objects were getting created, but after that you can see now garbage collector, these small red signs out here, you can see garbage collector is running, gc count, gc count, gc count, and you can see now the memory is flat. So the objects are getting created and the objects are getting collected, right? So very quickly in the interview, just remember garbage collector is nothing but it is a background process which keeps running continuously and claims any kind of unused managed resources. Can garbage collector claim unmanaged resources? Unmanaged resources means like objects which are created by C++ or objects which are created by some other programming language. The answer is no. Garbage collector cannot collect objects which are created outside the CLR runtime. Explain the importance of CTS. CTS stands for Common Type System. Now .NET is a framework and it supports many programming languages. So you can invoke the .NET library using C#, you can invoke the .NET library using VB.NET, F#, VC++.NET, VF.NET. So there are many programming languages out there which can compile to IL code. But now each one of these programming languages, when they define their data type, they have their own way of doing it. For example, you can see on the screen, I have C# out here. In C#, when we define a data type, we say int I equal to 0. And in VB.NET, we say dim I as integer, right? And in VC++, we can say some other way of doing it. Or in F#, we have some other way of declaring the data types. Now, suppose that I want to go and use this VB.NET code inside C#, then how do I go about it, right? There should be some common platform because the data types are so different of each languages. So what the .NET compiler does is, or when the compiler is compiling the code, it compiles them into a common type system. So it says that, okay, your VB.NET says dim I as integer, C# says int I. Both of them get compiled into a common type system which is int32. So in the same way for other data types, if you have string, if you have char, if you have double, if you have decimal, right? So common type system ensures that whichever language you code in, at the end of the day, your data types will get mapped to a common data type of the .NET framework. Explain the importance of CLS. CLS stands for Common Language Specification. So .NET supports multiple programming languages, right? Now these programming languages are different in terms of data types and also behavior. So the data types difference is handled by common type system, right? But the behavior also of the languages are different. For example, let us say in C#, C# is case sensitive. So in C#, if you say int I equal to 0, small I equal to 0, and int capital I equal to 0, both of them are different. They are different variables.